Welcome to Walkabout the Galaxy, the creative astronomy podcast where the science is universal, the opinions are personal, and the sponsor is unpredictable. We are Strange, Charm, and Top the Astroquarks, also known as Josh Caldwell.
Addie Dove.
And Jim Cooney.
Coming to you from the Walkabout Studios at the University of Central Florida. Be sure to stick around at the end of the episode for bloopers. Bloop. Our stumpers, there's one right there. It's bloopers, not snorters.
Sorry.
Our stumpers
My
are...
tongue is getting fat.
I heard about that on NPR this morning. They
Fat
think
tongue?
fat tongue is partly what causes like sleep apnea.
Really?
So when you lose
Yeah.
weight, it's partly your tongue actually loses weight, and that's
I
why you
had
breathe
no
better.
idea there was any fat on a tongue.
Really? Actually fat?
Fatty tongue.
That's what it said.
Wow. There's something that haunts me from my childhood called black hairy tongue. It doesn't not from my personal childhood, but this was like when you're a kid. When I was a kid, they're like you get these books of lists and things, or like weird stuff. And this was when the Guinness Book of World Records was maybe more cool for kids before the internet.
I'm very concerned about your childhood right now, Josh.
No, it's just like it's like the 1970s version of the internet.
Okay.
However, I found it. There was some list of creepy, weird diseases, and there's something called black hairy tongue.
Oh my gosh. Yeah, I don't want that.
Me neither. Our stumpers are hobbyal. You must explain your answers.
Okay.
Jim, your choice, your stumper,
Yeah.
is superficially easy.
Yeah.
In that your answer is easily predicted.
Right.
Jim's so
Maybe I'm
predictable.
going to go a different way.
Even
You don't
though
know.
our sponsor's unpredictable, but the stumper answer for Jim Cooney this week
Is predictable?
is predictable, but you must justify your answer.
It's still going to be easy.
Philately, is that right? Philately, philately,
Philately.
or numismatism.
Both fun words.
Have you been numismatized philately?
Is that like being hypnotized?
Not philately,
by
but when I
numbers?
was young,
You were numismatized?
I was numismatized. Yeah, I mean, when you're a kid, you like to collect just about everything, right?
No.
Many kids do. I don't know.
I was
did.
collecting descriptions of scary diseases.
Apparently.
Apparently. But I liked to collect
collecting
both
Legos.
stamps and coins when I was a little kid. I mean, like in Cub Scouts and stuff, there's like stamp collecting merit badges and coin collecting merit badges. Yeah.
Naturally.
There are?
Yeah,
Boy
absolutely.
Scouts is weird.
Yeah. I mean, both are becoming drastically less popular these days.
People are like, what are coins?
I will say that, yeah.
And what is mail?
Stamps are becoming less popular. Like the drop off in the interest in philately is more significant than the drop off in the
I think
interest
if more
in
people
coins.
knew what the word was, they would do it more. They would be
think so?
like, this is fun.
It's a little bit. They're both fun to say.
They are.
They are
But
both
why
fun
to
to-
try? Why stamps, not coins?
He didn't actually pick, I will say.
Philately.
Oh, okay.
Yeah. Stamp collecting is philately, and coin collecting is numismatism.
Mm-hmm.
I like stamps partly because
You can lick them.
it's
Oh.
easier to get a greater variety of them for less money.
Oh.
So coins
Cost money.
You know, coins are fine, and you would collect like all the various years of pennies and stuff like that. But you run out of that pretty quickly for the United States, and then the older coins get really, really expensive really quickly, and foreign coins are just harder. I don't know.
And they're heavy.
They are heavy. They're harder to
Stamps are more
harder to
colorful.
show. Yeah. So I enjoy stamps, and now I'm just into it.
There are Star Trek stamps. I don't.
Oh my
think,
gosh, there are so many Star Trek. I almost bought you a Star Trek stamp at the last stamp show I was at because it was awesome, and it was
Oh,
all
really?
like gold foil and everything. It was super pretty. It was great.
Ooh.
There are whole piles of Star
Why
Trek
didn't you
stamps.
buy it for me?
I don't like you that much.
Okay, fair enough.
I will next time. We'll see. It was expensive.
If it was price, I would have said you could have texted me. I could have Venmo'd you some money. Addie,
Yes.
Raspberry Pi
Delicious.
without an E,
Correct.
or Arduino,
Also without an E.
also without an E.
That's a complicated question. My answer is not simple, I would say today.
Simple
Choices
question,
aren't simple
complicated
either. I
answer.
don't know what the heck.
Jim doesn't know what you're talking
So
about.
what are these things? An Arduino is a microcontroller that we use to run a lot of our experiments. So it's a really basic thing. If you give it power, it runs through a code that's loaded on it, and it does a sequence of things.
So microcontroller meaning it's small or it controls small things.
It's a small controller. So typically they're small because it's based on a pretty small chip.
And they're like cost $20-$30 or something
Well,
like that.
there's some
or-
microcontrollers that are a lot more expensive.
But the
Arduinos
Arduino-
are super
the
cheap.
Arduinos
yeah.
is an
You can get them
inexpensive.
for $5 on Amazon.
Yeah.
Wow.
Yeah, but you can also get a really cheap a Raspberry Pi. And Raspberry Pis, though, are like an actual computer. So Raspberry Pis run an operating system. You can plug it into a monitor, and it will have
And a keyboard and a mouse.
And you can. It's like you're running a regular computer. And a lot of people have been using Raspberry Pis to do like new old arcade games. So you like plug it into a monitor, and people can play arcade games and stuff like that. So there's like Picade.
Yeah.
There's a lot of different.
Base
hacks for
Raspberry
these
Pi is
things.
only $35.
Pi Zero is only 10,
Oh wow.
but they're much more
Much
basic.
less powerful.
Yeah.
But yeah, I have a little Raspberry Pi computer at home.
Yeah.
It's just what you said, with like a $40, cheapo monitor,
Yep.
$10 mouse, and a $10 keyboard, and it's got a whole graphical user interface. And
Yeah, we have one running just in the background on it's called running Pi-hole to block ads on our internet. So like we don't get ads on our computers at home. It's pretty nice.
Oh, cool.
Yeah. Which one? I guess I'll probably pick the Raspberry Pi. It is a lot more capable. We use Arduinos a lot more for our experiments, just because when you're actually like just trying to run a bunch of different types of sensors and things like that, it's pretty easy to hook them all up to an Arduino.
Cool.
But probably a Raspberry Pi. I have a Raspberry Pi that I've been running in my vacuum chamber for probably like 8 months to a year now,
And it's happy.
and it's been super happy.
That's good, because you know what's running our spacecraft that we're launching shortly.
Do you know what's on my spacecraft that I already launched?
That's right.
Is a little Raspberry Pi Zero.
Raspberry Pi.
That's why this one's been
computers.
running in our vacuum chambers, because we've been testing
Testing it. Yeah. Well, today we'll be talking about Lucy, TESS.
In the sky with diamonds?
Yes.
No.
Lucy, TESS, GPS, and, of course, dark energy.
Yay!
Yay.
But-
Jim was like,
Yeah.
I like all those things.
But first, this episode of Walkabout the Galaxy is brought to you by the Hamiltonian. Sir Isaac Newton saw the apple drop, saw the moon go round, took his pencil to his paper, said, "Look what I have found. I call it calculus. It's for the best of us and also for the rest of us. A universal law that's never been seen before, describes the motion of every object, be it near or far. I call it gravity. It's the essence of brevity, F equals GMM over the square of R. But with just that, you will not get very far. You need my second law. It is without a flaw. Tells you how to make things move and all. But in 1833, a man was trying to see if this was the best theory. He saw that Newton's laws were too special after all. This man was after something much more general, and his name was William Rowan Hamilton. Yes, he was William Rowan Hamilton, and he said, "I have a better way. Just you wait, just you wait. Take some canonical coordinates, not those Cartesian ordinary nets. Then all the evolution you care to see comes from the evolution of Q and P, and they are related so elegantly by my new equations with the Hamiltonian, better than the Lagrangian. Leave behind Newtonian. Yes, I am William Rowan Hamilton, and the Hamiltonian will transform your life. Its symplectic structure cuts like a knife through complex dynamics and even quantum mechanics. So get your walkabout going. You just need Hamilton, William Rowan."
Very nice. Very nice.
The Hamiltonian, coming soon to Broadway.
Yes, I would go see that.
Liar.
Well, I don't know. Is Lin-Manuel Miranda in it?
Yes. I'm sorry, students.
working
I
on
couldn't
that.
prepare a class today. I was writing a song about the Hamiltonian, says Josh.
No class today.
Fortunately, you didn't have class today.
Yeah.
He
That's
has
true.
a couple days before class.
Yeah. Actually, I performed that for my class.
You should.
I will not.
When do you
I
get to,
sort of
when do you get to
have.
Hamiltonians?
It is
Ian?
on this podcast.
Yay!
Yes. Uh-oh. Let's cut it out of this podcast. Don't want my students hearing that.
Yeah. Look what you did.
yes,
Thanks, Hamiltonian.
This could-
I don't think that was a sponsor. I don't think that was the
could be-
phrase at the end. Coming soon to
it was
Broadway
not. Coming
like
soon to Broadway?
at any generic Broadway play.
Yeah.
Got
Yes.
it. I got it.
You did get it. Nicely done.
Thanks.
Space news.
Eddie.
We all look at each other blankly. Space news.
Space. Outer space.
Space news is a thing. I think the thing that we had talked about recently. So, well, first the AAS meeting American Astronomical Society meeting was happening in Hawaii.
Some poor scientists had to trek over to Honolulu.
I know. Those poor souls.
Okay, I'm not going to sing anymore.
Ooh, yes. Bust out some Little Mermaid.
That one at least has a tune.
It does. So was that song like based on a song from Hamilton?
Well,
I'm
I
curious
believe.
what the Hamiltonian was thinking.
Have you?
I have not actually listened to the Hamilton music.
Oh, have you, Jim?
No, I haven't.
Oh, really?
Yeah.
No wonder you were the worst audience ever. No, I'm just kidding.
Hey.
No, you were very supportive.
We were.
Yeah.
Have you seen it, Diego? Diego, our production assistant here, has been shocked, mortified by what he's just observed. It is inspired by
Hamilton.
the rhythms of those songs, but a very, very poor, pale reflection
Yes.
of them.
I see. Okay.
But yes, by the opening number, which is about Alexander Hamilton.
Yeah.
And he says, I am
figured.
Alexander Hamilton.
Makes sense.
His
Makes
name,
sense.
His name is a big deal.
Some of our listeners
And
probably have heard that.
He forecasts what he's going to do.
Okay. So the American Astronomical Society meeting has been happening. So there's been a lot of cool space news coming out from that, and it's very science space news, not as much of our typical like rocket launch space
Right.
news. There was a rocket launch this week, right?
Starlink went up.
Starlink again.
Yes, the 60
third
launch.
batch,
Yep. 60 more satellites, so there's 180-ish.
and one of them was not like the others.
Oh, really?
It was painted.
Only
differently.
one?
I think only one.
Painted very dark
Yeah.
or with a different sort of less
Some sort of
reflective
other
material?
coating. Yeah,
Okay.
I haven't heard any results
So
from
it's
that
like
yet.
just a test to see. I mean, but what are you testing? Why don't you
They're
just- why
testing to
not
see if
just
it's
do it
less
all?
reflective.
Oh. Why do you have
So
to
that
test that in
astronomers
space?
aren't as sad.
Well,
Don't you just know that if you paint it?
Yeah.
Sort of.
Your ultimate test is to actually do the thing.
But it costs money to do it, right? So they want to show how much different it is before they go and do that to all their satellites, probably.
Right.
Okay.
Yeah.
One of the other cool things that we saw in space news was that so there's this mission called Lucy,
Yes.
which you mentioned, that's going to study a bunch of asteroids, mostly Trojan asteroids, which are asteroids that are captured into orbit around Jupiter.
Well, not
around
into
Jupiter,
orbit
but-
around Jupiter.
Oh, sorry. Okay. They're
Yeah.
in a dynamical orbit that's related to Jupiter's orbit.
They're basically in Jupiter's orbit,
Yeah.
basically.
Yeah. Sorry.
Yeah.
I
To-
said that
to
wrong.
see-
They're
to
not
see-
orbiting Jupiter. They're orbiting in Jupiter's orbit. Yeah.
Right.
Right.
Yeah. Roughly 60 degrees in front of Jupiter and 60 degrees behind Jupiter at two of its Lagrange
I was
points.
to say we had a previous Lagrange point.
The Lagrange points
sponsor.
sponsored the episode.
Right.
Sponsored an episode earlier.
Yes. So, they're called Trojans because they like.
I don't know why they're
'cause they
called
stuck in
Trojans.
there or something like that.
It's
I
interesting.
think.
So the most of the asteroids are in what we call the main asteroid belt. Not very creatively.
Or out in the Kuiper Belt.
Well,
There's some asteroid-like objects, but mostly main asteroid belt.
okay. Yeah, I don't. Do we call things in the Kuiper Belt
We
asteroids?
call them Kuiper Belt objects.
KBOs. Yeah. So most of them are in the main asteroid belt, which are just outside Mars for the most part.
Mm-hmm.
And Jupiter's like 3 times farther from the sun than Mars is, and so the Trojan asteroids are also therefore like 2 or 3 times farther away from the sun than most asteroids.
I feel like I've asked this question on the podcast before, but why aren't they the Trojan comets?
Well, they
That's a great
don't
Why
exhibit
would
They don't-
asteroids
they don't
be more
exhibit cometary
preferentially- But
that,
but
what
is that
she
just
what
because
she
they're-
said.
So they're a dynamical population that's like is their own population, and they tend to more resemble other asteroids. Although some
Spectrally.
of them spectrally resemble some comets.
I'm just saying,
But-
why would asteroids be out? I mean, that's generally
Okay, we're going down the what's the difference between an asteroid and a comet rabbit hole. So we should just quickly just remind people the simple difference
right.
between them.
In the inner solar system, the leftover stuff is made up of rock and metal, and that's asteroids. In the outer solar system, the leftover stuff is mostly made of ice with little bits of rock and metal, and those are comets.
But it turns out those are like the very end members, and it's
Right.
a whole spectrum of tiny little stuff that's left over from solar system formation that probably has mostly mixtures of rock and ice.
Right.
Right.
And inner solar system stuff tends to be depleted and so not have like gas out, like jetting and stuff.
Right.
And outer solar system stuff still has those ices, so can
Right.
jet.
So how does well, anyway, this is going
So
too
the
far.
stuff,
I mean,
the stuff at Jupiter orbit is close enough that it probably has lost a lot of its volatiles too, right? So it's not going to
it's
be
sort of
cometary.
technically beyond what we call the snow line, the
Yeah.
distance from the sun. So Jupiter's moons are made of water ice. So you're sort of asking if you took one of the Trojan asteroids and brought it into the sun, would it look like a comet?
Yeah.
Right.
Yeah, and I mean, I would think that the things that would collect at those points would be things that were generally started their lives out there around that
Yes,
kind of
but
place.
Jupiter hasn't
get-
been out there probably all that time.
Yeah.
And so it
Maybe
probably
it's
didn't,
closer
it
and-
probably collected them from closer in. But it's an interesting question, and I don't have a great answer.
And some of the Trojans resemble Kuiper Belt objects, right? So there are Kuiper Belt objects that seem like they're cousins of Trojans. They have similar spectral features and things like that. So there's this whole, there's lots of debate, right? And that's why we're trying to go to the Trojans, is
Okay.
to see
Okay.
what
they really
things
look
they are
like.
and what they really look like,
All right.
and what
I'm
if
for
we can
that
compare
then.
them stuff. Yeah,
Yeah.
so you're excited about the Lucy
I
mission.
am. I
Great.
like the Lucy mission.
And I think we do have observations of some of them that clearly shows lots of rock
Yeah, yeah.
on the spectrally on
One
the
of
surface.
my favorite things about the Lucy mission is the orbit plan. So there's this diagram that shows all the different orbits that it's going to take over time, because it goes out and it circles around some stuff and it's going to a bunch of different objects. But it basically looks like a Princess Leia diagram. It's got a main circle and then these two buns on the hair buns on the side.
With Jupiter in the middle or something? Or?
It's because it goes out and it goes around Jupiter and then it does some loops around the two different groups of Trojans, basically. Yeah. It's
Yeah.
super fun. But so they have I don't know, a few objects. They had a few objects, maybe 7, something like that. And it turns out that there's probably one extra object that they're going to study, which is that one of the first satellites they're planning, or one of the first Trojans they're planning to go to, Euripides, maybe I'm saying that right, maybe I'm not, probably has a moon.
Oh,
A Trojan
I
with a
see.
moon.
Okay,
A Trojan
cool.
with a moon. So we've actually seen a lot of asteroids that have moons.
Right.
And so it's not surprising, or if it's a binary, but this one is probably, the main object is 6,000 times brighter than the little tiny satellite. So they were able to, they sort of suspected it might have one. So they did some observations and found that this one probably has a satellite. So that's cool.
One of the things I was getting to with how far away the Trojans are is they're relatively unexplored because they're so much further
Right.
away than the main asteroids. And we've had several spacecraft go to those on their way to the outer planets, but you wouldn't ever go to a Trojan en route to something else, because since it's in Jupiter's orbit, if you're going beyond Jupiter, you're flying by Jupiter, not by one of these little asteroids. You got to get your gravity assist from Jupiter.
Right.
And if you're not going out there, then you're not going to see it. So we don't know a lot about these things, and they also tend to be quite dark. And it turns out that the population, though, it's not just a tiny little, this a little quirky little group. The total number of
of them.
asteroids in the Trojans is comparable to the total number that's in the main asteroid belt.
What?
Yeah.
There's a lot of them.
blows my mind.
Yeah.
So it's this huge number of objects out there. As space, sort of orbits get bigger and bigger as you go out there.
My
One of the
world has been changed today.
Yay!
Awesome.
Great.
New
One
fan.
of the first objects. So the first object they're going to encounter is an asteroid that they're going to go by on the way to getting out to the Trojans, and it's Donald
yes.
Donald Johansen, which is all one word. But so asteroids are typically named after other
Right.
astronomers, either who found them or who've done other things. But I always read that one and think Don Johnson.
Right. I know.
That asteroid's going to be cool.
That is one of my favorite aspects about that mission as well. In the sort of space news named after ladies' names,
TESS.
kind of, sort of. Some news from TESS. TESS is an acronym.
It
Lucy
is.
is a name. It's not an acronym. We'll come to
That's
that
my
later.
favorite part of that mission, by the way.
So it's
The
named
name.
Lucy.
That I just said, forget it. We're not going to try and come up with some stupid acronym.
Yeah.
Let's just call it Lucy.
Yeah, I like that too. And Southwest Research Institute, which is running that mission, I think Alan Stern, who's there with New Horizons, just a name, and the spectrograph. A lot of the instruments on New Horizons also just had names like
Yeah.
Alice and Ralph,
Alice, Ralph.
named after the Honeymooners characters. But TESS is an acronym for Transiting Exoplanet Survey Satellite.
Correct.
And it's doing the same sort of thing that the Kepler mission did, which we've talked about before, which is look at a whole bunch of stars and measure over a long period of time very precisely the brightness of all those stars and see if you see a periodic dimming, which would be due to a planet crossing in front of it. So it's really technologically impressive they can do that. TESS is different than Kepler in that Kepler stared at one patch of sky for a really long time, years. TESS is scanning like most of the sky, but only looking at each part for a shorter period of time. So it's moving around looking at the whole thing. And it turns out that's okay. You would originally think, oh, if you want to see something like the Earth, you've got to see it for years because it takes 1 year for one little dip. But it turns out most of the stars are much smaller than the sun, and most of the planets we've been discovering are closer to them, and they take days or weeks to orbit the sun. So you don't actually need that long to see those orbits. Anyway, at the meeting in Honolulu that Addie was just describing, it was announced the first Earth-sized planet in a habitable zone discovered by TESS.
Yay.
A handful claimed by Kepler, but this is the first one discovered by TESS.
I heard a lot of press about this. This is the kind of thing that gets on CNN and
Right.
big news sites.
Yeah,
I guess it's a very close to the size of the Earth and in a habitable zone, and then people get all excited.
Habitable zone. Yeah.
Habitable.
I haven't heard you say that for lately. The star is
I'm a little
TOI.
eccentric.
Sorry?
No,
The star is TOI 700. It's got at least...
Such a great name.
Yes. It's got at least 3 planets around it, B, C, and D, moving from close in to further out. It's the third one out, TOI 700D.
Is TOI like test object identifier or something like that?
It
Probably.
probably is.
Usually they're like some silly thing.
probably
like
is.
That, yeah.
TOI 700D is the one that is in the habitable
habitable
zone, which is just defined by are you the right distance from the kind of star it is to
And-
potentially have liquid water
And
on
be
your
Earth
surface.
sized, if you're Earth sized or whatever.
Well, the habitable zone is the first part, then be kind of an Earth-like or Earth-sized planet is the second part, which this one is.
Well, sort of. The habitable zone also depends on having liquid water on the surface, not only because of temperature, but also because of
for
the
the
planet,
planet
planet
itself.
itself. Yeah.
Right.
Yeah. It's
But
a very
yeah. So
And so it's D because there's 2 planets, B and C, interior
to it. And they're probably too hot
Yes.
because they're also sort of Earth-sized.
Too hot.
But they're too close to the star. Good news, a lot of these stars that they're dimmer than the sun tend to be a little bit temperamental. And because for a smaller star, the habitable zone is narrow, it's a tiny region you have to be in. You have to kind of get lucky. And then if the star, and it's close to the star, and if the star has big flares, that's bad. But this one doesn't seem to have lots of flares. It's
That's
about
good.
that's good.
the star is 100 light years away.
Hey, we could get there.
Right nearby.
Could get there in a jiffy.
You could get there. Well, if you were going fast enough, you could.
What about in a skip?
How long is a skip?
I don't know.
Is
long
the
is
skip a thing? Because a jiffy is a thing.
Yeah.
Yeah.
It's a
we talked
time
about
that's
that one
really
time.
short. Yeah. This star is in the constellation Dorado, which I kind of like.
El Dorado?
The dolphin?
Isn't it? I don't know.
I don't know.
No, is it?
No, I don't know.
Dorado?
It's 40% the mass
A fish
of the
dorado
sun.
is a dolphin.
Oh, the dorade in French. Yeah.
Yeah.
This star is about half the size of the sun. Its surface temperature is about half the temperature of the sun, so you got to be closer to it in order to be in the habitable zone. And it is about 20% larger than the Earth.
Okay.
So it's Earth-sized, but its mass, if it's same composition of the Earth, would be significantly larger than the mass of the Earth, maybe twice as much or close to twice as much. But that depends on composition, and we don't know anything about the composition of this guy.
Yeah,
Right.
you can't get it.
It gets about 86% of the energy, solar energy from its star that the Earth is getting from the sun.
Could
Pretty
do.
good.
Could
Which
do.
is decent.
Yeah.
37-day long
Does that assume
year.
like, yeah, okay.
Yeah. The inner 2 planets, B and C. B is very nearly the size of the Earth.
Oh,
10-day orbit.
really?
At a 37-day orbit from that star, would it be expected to be tidally locked to its star or no?
Excellent question.
Thank you.
100 for that question. And then the middle-sized one is significantly larger, 2.6 times larger than Earth.
Oh, okay.
So
but
it's-
interesting. We think they're all
they're not
rocky
giants.
planet sized.
They're not
interesting.
giants. The middle one is sort of in that Neptune kind of
Yeah.
region or super Earth
Super Earth.
sort of
Definitely
region.
super Earth.
It takes 16 days to orbit. So they're all
Interesting.
short orbits and yeah.
Because a lot of the systems still that we have are mostly this far in close stuff is still giant planets. So it's
Right.
interesting if they're starting to find smaller planets closer in, systems of smaller planets
Right.
closer in. That's cool.
Yeah, and
They've
multiple
also
planets
found-
is cool as
Yeah,
well.
yeah. They also found they made this week their announcement of the first planet orbiting a binary star system.
Oh,
So a Tatooine planet.
Tatooine.
Except I don't know if it's a desert planet, but it's a planet orbiting 2 binary stars.
Let's just decide it is. Let's just decide it's Tatooine.
the desert planet
But
TOI
there's already one that's
701.
called
Blah, blah,
Tatooine,
blah.
right? That we discovered long ago with.
I don't know if we actually named it Tatooine.
Well, it was,
It was
yeah, so
always called
it
that in
was-
the press. Yeah, it's like
Yeah.
the second or third one of those.
Right.
That we've
Yeah.
found. Probably more than that. I don't know.
Yeah.
Only the first one ever gets announced. Just for reference, Dorado is named after sort of the dolphin fish or maybe the swordfish.
Good
It's
call, Jim.
because known
Thanks.
as the Dorado in Portuguese.
Yeah, there's a lot of confusion because dolphin, of course, we think is the marine mammal, but there's also a fish called the dolphin.
All
Very
right.
common here off the Florida coast.
Dolphin fish.
What does El Dorado mean? Does that mean the dolphin fish?
Probably.
Dorado is another word for that fish. Yeah.
I have learned something. You
Yeah.
have learned
I
something. We just need to teach Addie something.
Yeah.
Now she's
Good
known
luck.
so
Yeah.
far. She's known everything on this episode.
I didn't
so-
know any of those things.
Well, maybe you won't know the answer to the trivia question.
Ooh, I'm ready.
Okay.
Challenge accepted.
We talked about the Lucy mission.
We did.
You told us
True.
all about it. It is named after the I want to say hominid,
That's
but what I
correct.
saw said hominin. I don't understand that. Anyhow, it's
Hominid.
named after the fossil of a hominid
Mm-hmm.
species. The particular individual fossil was nicknamed Lucy. It was
Mm-hmm. Correct.
discovered in what is now Ethiopia in 1974. Lucy lived 3.2 million years ago and is not a missing link. In other words, her species was not a direct lineage to Homo sapiens, but on a branch.
branch.
So if they had continued, that species is extinct. Had it continued, it would have been a cousin of ours, like the chimpanzees and gorillas are. But it has taught us a lot about human origins, which is why the Lucy mission, which is meant to teach us a lot about the origins of the solar system, is named after that Lucy. The trivia question
Yes.
is, where did the hominid Lucy get her name from? Why is that fossil named Lucy? And it's multiple choice.
Okay,
Oh,
great.
okay.
I got this then.
I think
Hey,
I remember it.
wow.
Yeah.
Okay. Good for
I
you.
think I've heard this
I,
story,
am-
but I
I
can
probably am not going to get it right.
I'm nervous now for the second time this episode. A, they were listening to the Beatles song Lucy in the Sky with Diamonds in the camp after the discovery.
Okay.
B, Lucy co-discoverer, oh my gosh, is this the same person as the asteroid or is this just a crazy coincidence? Lucy co-discoverer Donald Johanson. I'm not making this up.
I don't know.
It could be.
Maybe it's named after him.
It would be awesome if it is.
That'd
we have
be
to
so
check
perfect.
that.
We'll check.
Donald Johanson's name of
After
the
we answer the
asteroid
trivia, I'll
that the
check.
Lucy spacecraft is going to happen just by happenstance fly by.
Well, maybe they named
was-
that asteroid because it was one they found and it
Maybe,
didn't have a name
maybe,
yet.
yeah, maybe.
That would make sense.
That would tie in.
Yeah.
Anyway, that's cool.
So exciting.
Lucy co-discoverer Donald Johanson was a fan of Lucille Ball and was teased about how he was always talking about "I love Lucy," and so he
That's how
loved
they
this.
named it.
Well, so it got named Lucy,
Okay.
sort of as a joke at his expense, and it stuck.
Okay.
C, co-discoverer Mary Leakey named it after her mother.
Who
Guess
was
what
all-
her mother's name was?
Lucy.
Right. Or D, expedition leader Maurice Taeb, whose name I may be mispronouncing, had a daughter named Lucy, born 1 month before the main fossil parts were discovered in November 1974. The expedition began in 71, and let's just say that his daughter began during the expedition. But she was born in Paris, not in Africa, where Lucy was discovered. It's named after
Okay.
her. Those are your choices. We'll come back to that after we have now moved beyond our solar system and beyond ancient history to the cosmological realm and perhaps even more ancient history.
I was thinking about the opening title for Star Wars the other day, maybe on the last podcast, and I forgot to say it. But since we're going back in time, as you just said, and going far away, right? They always say in a galaxy far, far away, or a long time ago in a galaxy far, far away in Star Wars,
They
right?
do always say that.
Yeah.
But that's because it's always a long time ago if you're in a galaxy far,
It
far
is.
away.
That's right.
That's how it works.
Duh. It's redundant.
All right, that's all.
You should
I'm
go.
so
You should
clever.
go see the movie. Let's talk about dark energy and then come back to the Earth.
Okay.
All right, dark energy.
Again,
We always look at
jeez.
Jim when we talk about dark
Dark
energy.
energy.
He brings a lot of
Because
dark
I'm
energy to the
dark and
room.
brooding, yeah. Like,
Oh, yes.
That's why
He's
I'm
so
very so
dark and
popular with
brooding.
the ladies.
He's
I'm
a
very
sort of
dark and brooding, yeah.
Don Juan,
Yeah.
Phantom of the Opera kind of dark.
You only really know that if you're watching the YouTube thing, but
Right.
100%.
yeah. Dark energy. So I believe this is also at the AAS meeting in Hawaii. There was some folks talking about a potential discovery that was really going to rock the world of cosmology and dark energy. So the Nobel Prize that was won for the dark energy stuff was so basically the original idea of dark energy was that there's something pushing the universe away faster and faster and faster, something accelerating the expansion of the universe. And the way we found that was by looking at type 1 supernovas. So these are supernovas that are supposed to always be the same brightness. And you look at them
Making them a standard candle.
a standard candle. So if I look at them in distant galaxies, I can figure out how far away that galaxy is. And if I know how far away that galaxy is and how fast it's moving away from me, I can figure out how the universe is expanding. And since I can see these things really far away, that helps me look at how the universe is expanding now versus how it was expanding earlier versus even earlier.
These
You
are
can
the
look long ago in a galaxy far, far away.
Right.
These are the
saying
the astrophysical version of a neon sign that says "I'm a 100-watt
I'm 100
bulb."
watt. Exactly.
Seems like we just talked about
We
it.
did, yeah. We
So these
love
are these,
standard.
but they're great because they're huge and super bright.
More than 100 watts.
A little bit more than 100 watts.
There's a website that sells LEDs called Super Bright LEDs. Maybe
Yeah.
they got it from that.
Maybe. But that result, finding that the universe was expanding faster, or the universe is expanding faster now than it was, is based on that stuff, based on the idea
That we
that
know what we're
all
talking
of those supernovas are the same brightness.
Yeah.
That brightness
fundamental
doesn't change.
assumption
Right,
in
that's
there.
the fundamental assumption. That and that would be really screwed up if, for example, supernovas, type 1a supernovas, were brighter or less bright earlier in the universe.
So overall, the brightness of a supernova is set by the fact that of type 1a supernova is set by the fact that it's always basically the same like amount of material
Right.
that's being converted, and so it's releasing about the same amount of energy.
Right. That at least is the idea, right? So that's our theoretical understanding of this. It's like a bomb that's always the same because it's the same thing always. It's a star that goes from just under this Chandrasekhar limit, which is the limit of how big a white dwarf can be, to just over. So since it's the same size, but you have to test that, right? I mean,
Yeah.
you have to look at a whole bunch of type 1a supernova and make sure that they are actually all
And
the
how
same
the heck do you
brightness.
do that? Because there aren't any nearby.
And there aren't too many nearby, but we know of lots of them. We know of hundreds and hundreds of these things, and if we have some other way of measuring the distance to the galaxies in which those things live, then we can, even if we don't know it really well, we can. If we have a whole bunch of them, we can at least statistically look at whether our ideas are right. Anyway, the news that was announced at AAS was that a group working on this in Korea, I believe, found that the brightness of these type 1 supernovas is not the same. When you go back in time, when you have a different stellar population in younger galaxies, then that these type 1 supernovas are of a different brightness.
Because I was going to say, not only, you were saying if we know the distance some other way, we calibrate whatever, but also we know physics, right? Physics is part of it. It's
Right.
like understanding what is going on
Right.
in the
Yeah.
type 1a supernova that makes it a certain brightness.
Right.
Exactly.
Like even if you've got a neon light bulb and you're putting a certain amount of electricity and it's got a certain characteristics, you can calculate that it's going to be 100 watts even if you don't measure that. So that was part of it too, right?
It is part of it, right?
But then it turns out that those stars aren't the same stuff.
It could be, right? So, so that was a little bit
So when
worrisome.
they go,
Here's the thing:
so when they go bang, it's a different set of gunpowder in there.
possibly, right? That might be the
You got
so.
some like cobalt that makes it turn blue or whatever.
Cool.
We're talking
Did you
about
do that
fireworks,
when you were a
right?
kid?
No.
Oh.
So that was the big announcement, and this was a little bit worrying because that's the fundamental assumption on which all these measurements are made. So dark energy, and these people won the Nobel Prize for this, and so forth. So this would be really big news if we were wrong the entire time about the brightness of these type 1a supernovas.
But there's been a lot of measurements. Like people have continued to take these measurements and continued to study this stuff.
That's right. But
But there's this new study.
But there was this new study that claimed that, in fact, the brightness of type 1 supernovas is correlated to how old or young the stars are in that galaxy. Here's the thing.
Uh-oh.
Okay.
They're wrong.
Oh, maybe.
They're probably wrong.
Probably.
Yeah. Since that paper was put out, so it was put out first as a preprint, but it's been accepted to the Astrophysical Journal. So it's not like it's a garbage paper or anything. These guys are smart folks. But it turned out that the sample they used was about 30 supernovas. In 30 different galaxies that are not too far away. But the same study has been done with hundreds of supernovas and said a different thing. It looks like something they've done is wrong. And I also looked at the plot of the data that they had where they suggested this thing, and
it
was one of these real mushy like there's all these dots, and you can draw a lot of different lines through those dots
I hate
that fit the data. And in fact, some of their data was very weird. Like they had a plot where on one of the axes was age of the galaxy, and some of the galaxies were older than the age of the universe on that plot, which is obviously wrong. And
it's because they had they had done some extrapolation to predict the age.
There's a bunch of weird things. So in the end, even though I got you all excited by telling you that maybe dark energy isn't a real thing, turns out it probably is.
Oh.
In addition, of course, there are other.
Nice if it wasn't a real thing.
It kind of would be,
because
but it would be a
it's
problem.
called dark energy because we don't know what it is.
That's right.
Well, also,
but it solves a bunch of our. I mean, like
that's true.
The supernova thing was the first place we saw it, the first reason we had to believe in it. But since then, there are several other independent lines of research that tell us it's there.
The dark energy is there.
Things with cosmic microwave background and so forth. So it would be problematic for our whole system if it weren't there. There would have to be a lot of new physics.
Well, that's fun, and that's exciting.
Which would be fun. It would be fine.
And dark energy is depressing for those of us who don't like the ever-accelerating expansion of the universe.
Right, that's right, because that means the universe is going to die in a whimper, an infinite
time death of the universe.
Yeah.
Yes.
Yeah,
I'm not a big fan of that.
You're not immortal. It's fine.
But I might live for trillions of years.
You might.
Yeah.
Right.
You might.
So we had a whole discussion about whether...
If you really think about it, you already have, because the molecules and the atoms that are in you come from stars that lived trillions of years ago.
Sagan-esque.
Not trillions.
Well,
universe is only
that's true, not trillions.
14 billion years
billions
old.
of years ago.
Yeah.
And they will continue for billions of years.
Right.
Probably trillions of years.
Maybe trillions.
Yeah.
Very Sagan-esque of you. Okay, so that was quite the whirlwind tour of dark energy.
I brought you up and then I brought you right back down.
I've got to catch my breath.
Such dark energy, Jim.
Let's come back to Earth before we get our... Yeah, right.
That's our sound for coming back to Earth.
Last time we were talking a little bit about we've had some very interesting sort of archaeoastronomy things.
Those are always interesting.
Learning stuff about past magnetic field reversals from funny things like the tree rings in New Zealand, and then there was something else about the aurora that were picked up that we talked about in the last episode. But
I just saw an article that one of the oldest books known in the Americas is actually like recordings of astronomical events.
Yes.
They
astronomy,
found an
the
ancient,
oldest of the sciences.
From some more native populations, and they found this ancient text. It's pretty cool.
Neat.
Now we're all slaves at some level or other, not all of us, but to our phone GPS receivers and getting around, and navigation's become a little bit of a lost art. But there's some other fun unintended or unanticipated benefits to those satellites.
To having GPS. Yeah, there was an article out recently based on a paper. And there's actually been some funny sort of joke ideas for how, since everybody has phones and GPS and stuff like that, about how you can start using, like, taking people's data and using it to understand, like, migration patterns. And then somebody was saying, like, it would be a really good earthquake predictor, cats. And, like, having, like, sensors on your cats. So when they run away, something's going to happen. And if a lot of cats are all moving at once, like, oh, no, maybe there's going to be an earthquake.
Yeah.
But this is a little bit more science-y. I think there was even a cute acronym for that one. That's probably pretty great. But this is using some satellites to actually study. So you put sensors at different locations on the Earth, right? And then you can track how those sensors move over time and actually look at long duration movement of different parts of the Earth, but also look for things like shifts that are maybe going to preclude an earthquake, and so you can actually predict an earthquake. They're gonna you're gonna see movements, and it's like, oh, maybe an earthquake.
This thing's about to slip.
How does a movement predict an earthquake?
So
an earthquake is a movement.
Well, I know. But what kind of a movement predicts that there's going to be an earthquake?
So
Is
they
it like
have
rise in the.
So most of our sort of prediction stuff comes from seismometers right now that show like little movements and little trembles before big things happen. So
Right.
a lot of times before a big fault. I'm bad at earthquake words today, apparently. But like a big fault slip or something, right? You have a lot of little bit of sort of like shifting in motion that shows you what's going to happen before the big thing happens.
Okay.
Yeah.
Because some earthquakes are caused, right, by things sliding along each other, and you're like building up
some
friction
are
and
like-
friction and friction, and then it slips.
Right.
And that big sudden shock is what is the earthquake. And so I think that so you can look at how things are moving relative to each other to see how they're going to change.
Right. I mean, so I don't know, but I could imagine that if you saw things changing their pattern of movement, and there's, maybe some data from previous earthquakes that you see a certain pattern. If you see that pattern
Yeah.
occurring again, then you would say, okay, that's the kind of change you expect to see before you're now building up tension and the thing's going to slip loose or something like
So is this
that.
just an
And
idea,
so-
or is this a thing
No,
that's
so
they're
they
putting into
have
practice?
they have a bunch of these. They have a bunch. They've been using the GNSS, which is one of the GPS, the Global Navigation Satellite System, is one of the GPS systems we have in orbit, and ground sensors. So those are the Earth orbiting satellites, and then they have receivers on the ground that can give precision of like a few centimeters precision in terms of their ground location. And so they've actually done an initial proof of concept. And have done some seismic monitoring, and they show that you can actually see before a couple of different earthquakes, you can actually see some of
Some
the
telltale
motion,
signatures.
Some telltale signatures, yeah. So it's basically doing seismic monitoring with Earth orbiting satellites.
GPS is crazy.
It is.
Right?
One of the to bring this back quite naturally and organically to Cassini,
As one does.
as one does.
Everything
Every
comes
episode.
back to
Right.
Cassini. So
One of the final science achievements of that mission was measuring the mass of Saturn by tracking the Doppler shift of the spacecraft's radio signals that flew really close to Saturn. And then you have to take into account everything that's causing that Doppler shift to see what is left that's from the mass of the planet and the rings. And in order to get that working right, they had to make a correction to the location of one of the ground stations, one of the big giant antennas on the ground that picks up the signal that had moved due to continental drift by 10 centimeters.
wow, that's a lot.
And that 10 centimeter change resulted in enough of a change in its speed due to the rotation of the Earth, because it's on a different place on the Earth now, that it made an actual difference in solving all of those data and equations to get the mass of Saturn and its rings. So it's things
That's
that
crazy.
Einstein wasn't thinking about when he came up with general relativity.
Unbelievable precision. By the
Yeah.
way, it's just as a random other end of episode bit of space news related to earthquakes. There was just a reasonably big earthquake in Puerto Rico.
Yeah.
So this is UCF related news because we run the Arecibo the telescope down there, and
It
what
was
happened to it?
shaking. It was shaking.
It was
was
shaken.
shaken. I think
yeah,
it's okay,
It seems to
but
be that the
it
structure's
lost power.
mostly intact. Most of the island lost power. Arecibo has backup generators, so they're generally okay pretty soon after. But they are not allowed to like use some of the structures until they get some structural
Yeah,
certification.
there's a
and
big
stuff like
receiver
that.
suspended over that dish, and they have not gone up to inspect it
Right.
because they want to make sure that it's safe to go up and inspect it. And they saw it wobbling around
Yeah,
during
scary.
the earthquake, so
Yeah.
it is
I
scary.
hate to see that thing crashing down into the dish.
One of the
No
crazy
kidding.
things to think about with GPS is how much we depend on it now here on Earth. And if you go somewhere like the moon, right, there's not GPS on the moon.
We should
Yet.
do something about
There,
that.
I mean, there are people talking about how
Yeah.
you set up navigation satellites around
Right.
things like the moon or
Yeah.
Mars or whatever when you're going to go there, because it'll be important. We're so used to it at this point that like
Yeah.
going back.
Yeah. Our trivia had to do with Lucy,
Oh, yeah.
the hominid, and the mission. And I was super excited about one of your potential answers has to do with Donald Johanson, co-discoverer of Lucy. And you're right, that asteroid was named after him
Oh, you
because
checked.
of his role
Okay.
in discovering the fossil Lucy.
Great.
That's awesome.
So they were flying by some asteroid with some crazy
That
long
didn't have a
number
name.
that didn't
Yeah.
have a name, and they said, okay, let's name it after somebody
fun.
associated with the discovery of Lucy. So it's not a coincidence in that sense, but it is a coincidence that he features in our trivia question
Okay.
related to that same mission.
Not really a coincidence.
Why is the hominid named after? Why is it named Lucy?
Mm-hmm.
What is it named after? Beatles' "Lucy in the Sky with Diamonds."
Mm-hmm.
Donald Johanson's fandom or appreciation of Lucille Ball, in particular the show "I Love Lucy."
Mm-hmm.
co-discoverer Mary Leakey's mother, or exhibition leader Maurice Taib's daughter? 4 Lucy's. Which one do you choose?
I thought I had read about this, but then none of those 4
Sounds right.
sounds right to me. So
Nice.
I'm going to guess I Love Lucy.
I am going to guess Beatles.
It is the Beatles.
I thought so.
Nice.
I was like pretty sure even before you gave us the options that it was the Beatles, and
Yeah.
I was singing that song earlier.
Right.
Fortuitously.
Yes.
Yeah.
So, yes, they were, in their camp, and for whatever reason, that song had been playing, or it maybe played a few times, and somebody in the group said, let's call her Lucy.
Yeah.
And that's what stuck.
Lucy in the Ground.
Is it
With diamonds.
Is it definitively determined that it was female?
Yes.
Yes.
Not very tall, but an adult.
Yeah.
Recent research suggests that her...
But height
that
alone can't be it, right? Because
No. They're like pelvic structure and
There's
stuff
all
like that.
sorts of
is pretty well
stuff,
known.
and yeah, it's a fairly, as far as these things go, a fairly complete fossil, and it's
Right.
amazing the kinds of things they can figure out. In the last 10 years or so, they did some new analysis with CAT scanning and trying to figure out, like, how did it die?
It's 40% of the skeleton,
Right.
which is pretty good.
Yeah.
And so damage is consistent with her perhaps having fallen forward by a few meters, perhaps out of a tree. The skeleton suggests strong upper body, but the feet are not grasping feet, so they're walking around. It's a walking around animal, but probably may have spent some time in trees based on the upper body strength. So,
Apparently fossils also have catalog numbers like stars do. So the catalog name is AL288-1.
AL288-1
Yeah,
is the Lucy name.
Lucy's nicer.
Lucy is catchier than that.
Yeah, and apparently in Ethiopia, the assembly is known as Dinkanesh, which means you are marvelous in the Amharic language.
Nice.
That's nice too.
Well, it may have felt like sitting through an amateur musical production.
Hopefully not that
It was
painful.
just another episode of Walk About the Galaxy. If you like this episode of Walk About the Galaxy, against all odds, write us a review, pseudo hip hop.
You know what our memoir is going to be called? Walk About the Galaxy, Against All Odds.
Right. Stage and perform and post it on YouTube, or just write one on whatever you write things on with Apple now that iTunes isn't a thing anymore. Because it isn't,
Oh, yeah.
but I don't know. Be sure to like us on Facebook to get all our updates, and check out our website, walkaboutthegalaxy.com. Subscribe to our YouTube channel, Walk About the Galaxy, where you can see Josh trying really hard. Catch up on old episodes wherever you get your podcasts. Thanks to our listeners in Australia, and our best wishes to everyone there dealing with the ravages of fires. Follow us on Twitter
At walk_the_galaxy.
and ask us questions anywhere using hashtag WalkaboutTheGalaxy. Our theme music was composed by Richard Jerusik. Our production assistant and video guru is Diego Rodriguez. I'm Josh Caldwell.
I'm Addie Dove.
And I'm Jim Cooney.
We're the Astroquark, signing off until the next episode of Walk About the Galaxy.
Bloop.
That's your...